Okay, we're going to kick it off here. Good morning or good afternoon or good evening, depending on where you are in the world. Thank you for joining us for our webinar today on advanced remote monitoring for industrial Ethernet. This is me. That was taken back during the pandemic, so obviously you can see I have less hair and more gray. But and I'm nearly 20 years. I'll be 20 years in October, so 5 months away from 20 years of experience. A little bit about Grid Connect. Grid Connect started in 2003 as a distributor manufacturer of industrial networking products. And the products we'll be featuring today mostly are from HMS Anybus. Formerly Procentec. HMS bought Procentec a few years ago and now are rebranding, in the process of rebranding the Procentec product line into Anybus Diagnostics. Grid Connect is a master partner. That's the highest level of distributor for HMS and Procentec. And we do have other partners. As I mentioned, we're a distributor. So here's a few of our other partners, and we may see a few products from some of them later on. Our topics for today, we're going to go over industrial Ethernet monitoring, why it's important. We'll go through some of the tools, a lot of the common problems. We're going to talk a lot about these two products you see on the right, the Atlas2 Plus and Osiris, which is the software that runs on it. And next to it here is another product called the EtherCAT 2. We'll also be talking about that. We'll go into the difference between passive and active monitoring. Time permitting, we'll do a brief demo on the Atlas and take your questions and answers at the end. But if you do have questions during the webinar, please feel free to click on the Q&A button. It should be at the top of your screen, and just type in your question. And if we can get to it in real time, or if I have a couple folks monitoring the Q&A, Gary and Tim, they will answer you in the Q&A if it's something easy, and if it's something they want to save for everyone to hear and see, we'll do it at the end. And with that, let's get started. So industrial Ethernet monitoring. Well, it's probably obvious, but there are more and more devices, industrial Ethernet devices, connected than ever before. Networks are getting larger and more complex. A lot of operations run 24/7 and have little to no scheduled downtime. So preventative maintenance has to really be scheduled in advance. And when problems occur, it can shut down the whole operation. To compound things, these industrial networks have a variety of protocols that they use. Each vendor has different tools that you need to use to build and maintain the networks. And there's lots of rules that the maintenance staff need to know about cabling, grounding, and shielding. So in summary, a lot of information is needed to run an industrial Ethernet network, to both manage them and troubleshoot them, and to get to problems before they become an outage. So there are a number of tools available. Of course, there are the devices themselves in industrial networks. They often have diagnostics that they can provide. There are engineering tools from the PLC manufacturers, typically, so Siemens or Rockwell or Allen Bradley. And then there are cable testers for the physical layer. There are tools that are network browsers. There are monitoring devices like our Atlas that we'll talk about here later. There are different diagnostic tools and utilities available through some of the trade organizations. There are tap tools available, so you can use mirror ports or taps to get information from networks. And there are IT tools like Wireshark also that are used in industrial Ethernet networks. So a lot of industrial Ethernet protocols support device diagnostics, and most of the organizations that promote those technologies tout how great it is that the devices can provide diagnostic information to the PLC. But it's not the only thing that you need in order to run an industrial network. Device diagnostics are nice. They tell you about problems with an individual device on your network. They won't tell you about your entire network and how it's running and how it should be running. And they rely on the protocol, whether it's PROFINET or Ethernet IP, to report any diagnostic information to the PLC. So it could be things like an IO slot failure within a remote IO, or a wire break on a digital IO, or some devices will report that they need maintenance, periodic maintenance. It could be based on time or a number of cycles and things like that. So all of that stuff is reported in through the protocol. So PROFINET from the device to the PLC master in that case. And then, if you want to take action on those that people in the plant or can see, you either have to do some programming in your PLC or something on the HMI so that they can know, oh, this device has a problem. They don't, if you're not looking at the protocol, you won't know that the diagnostic occurred. And there's also engineering tools that you can use to pull out the diagnostic information from a device. So you just connect a laptop with an engineering tool on it, and you can, the devices will save or cache their diagnostic data, and you can remotely pull out that diagnostic data, but that's another tool you have to use. And as we can see over here, the protocol layer, PROFINET, Ethernet IP, run kind of at layer 7, but there's a lot going on underneath that. So what about all those other layers? Well, there's lots of common problems that pop up in industrial Ethernet networks. The network loads can become too high, so the network doesn't run efficiently or at all. Industrial Ethernet networks are deterministic and real-time, and so network load is a very important thing. There's also individual port loads within switches. There are problems with how people design and lay out their topology. There's a lot of options and topologies that can go on. There's line depth. So a line depth means how many switch hops does it take between a device and the controller. So if it goes through 7 switches, for example, every message back and forth, that can cause problems as well with latency and other things. There's cases where you have 2 devices, like let's say it's 2 remote IOs from a particular manufacturer, and they have different firmware loads. So one has the latest and greatest, and the other one is 5 years behind. And these differences can cause problems in how the network runs. It's also happens that sometimes you get duplicate IP addresses. So 2 devices in the network get the same IP address, either by mistake or by someone plugging in a laptop that they don't have the right IP address assigned to it, and they duplicate one already in the network. So this causes problems. A lot of the protocols have the concept of a device name, for example, PROFINET, and you could either have the wrong or missing device names. And sometimes the PLC programmer and what they actually name the device don't match, and that causes problems. Switches, as we talked about before, just aren't able to handle loads. There's also an issue with devices having individual problems or bugs. So it might not be something that they report with a diagnostic, it's just a faulty device. And this happens also quite often with non-certified devices. So for PROFINET and Ethernet IP, there are certification test facilities that test any new device to make sure it conforms to the protocol. And some device manufacturers skip that step, either at the request of their customer or because it's just a specialty thing that doesn't, they don't think they're going to sell a lot of. But anyone who puts a non-certified device on their network is taking a chance, of course. And then there are redundancy issues, either through redundant rings or other topologies that support redundancy that can also lead to problems. And oftentimes devices can just have configuration errors, I/O configuration errors. So lots of places to look for problems when things go wrong, and lots of different tools and lots of different things that could be needed to help figure all that out. So network loads. Let's take, for example, this picture here. We have a device down here, and on this link, it's occupying 5% of the bandwidth. And then it goes into a second device, which has a 2-port switch. It adds 5%. So now on this link, we have 10% utilization. And then likewise from these, we get 10. And so up to the controller, these all aggregate up. So we're 30% network load. Even though down here, if you look in here, it looks fine. Up here, 30. Oh, okay, still not too bad. But then you add other traffic on the network, like vision systems, other things like that. Now, one thing that a lot of people don't know is it's possible to reduce or adjust the cycle time of an individual device. So, and that's possible, I think, in both Ethernet IP and PROFINET, where you can say, for example, this device needs to report every 8 milliseconds, and this device needs to report every 2 milliseconds. So they have different, the PLC asks for the information at different intervals. And so, for example, in that last example I gave, this device happens every single cycle. The PLC will ask for its information and read inputs, write outputs. Whereas this one down here, it might do only every 3 or 4 cycles. So that reduces network load. As I already mentioned, it's not a good idea to add non-control system traffic like we see here with this camera onto the same network as your control system, because that will increase jitter and can cause switch overloads and things like that. And then if you have multiple switches, how you place them within your network, network design is important in terms of network load. So if you have a choke point in your design, it'll show up pretty fast, or it might not show up until you slowly add new devices and all of a sudden you go into overload on a link. Just to kind of talk about the number of nodes and the update time, as I was mentioning earlier. So if you had 200 nodes on a network, that'd be a pretty large network, and they all had a 2 millisecond update time, your network load would be somewhere between 80 and 90%. Whereas if you used a 4 millisecond update time, now you're down between 40 and 50, and on 8 milliseconds, almost 20%. So a big difference, but even if you have 200 devices and only half of them are on the 2 millisecond time, and another quarter are 4 millisecond, and another quarter are 8 millisecond, that will reduce your overall network load, probably somewhere down in the 50% range, for example. All right, so we talked about switches a little bit. I just want to get everybody on the same page about industrial Ethernet switches. When we talk about other protocols, field buses like Profibus, every device sees every message. So if a controller were to send out a message on a Profibus network, every single device would see that message, and then whichever device it was intended for would respond, and the other ones would stay quiet. That's all fine and good for those field buses, but in the Ethernet world, with all the other possible traffic, it's really important that switches do their job, and their job is to reduce collisions. So Ethernet can have collisions, but switches kind of stop that. So messages don't go everywhere. In the case of communication between the controller and this device X down here, the controller would send a message to port 1 for device X. The switch would say, aha, this is for device X. I know that device is on port 2, and it would send it down port 2. It does not send it down port 4. So these devices and these links would never see a message from this controller to this device. And similarly, if you had between the controller and device Z, it would go through these links and out port 1. So port 1 and 4 for device Z and Y, and port 2 and 1 for device X. So there you go. And switches do buffer messages because of the collision things that I was talking about. So they have to control the flow of messages through the switch. And when switches get into overload, there's not enough buffer space, for example, they start discarding messages. And by discarding messages, that means they throw them on the floor. Essentially, they're just discarded. This works fine in IT networks because of the protocols. They'll retransmit and it might not be time sensitive. And so it's okay. But in a real-time control system, discarded messages are not so good. It can really throw off a process. So, but there are some provisions within switches when it does go into overload that it would process priority messages first. For example, if you're using a VLAN or a PROFINET IRT, those messages get special treatment and the switch knows to prioritize that traffic over regular traffic. And so the discards would only happen on the regular traffic in that example. All right, so these are actual network topologies. So this is actually a big ring, and you can see all the nodes on this industrial Ethernet network. This was taken by a support engineer for HMS Diagnostics / Procentec, as was this one. And you can see these are pretty complex topologies. There's a mixture of things going on. This was actually one big ring, but when they made the drawing, they folded it over. So if you think of this as just one big ring with lots of stars off of it. But, you know, with these large networks and mixed topologies, there's a lot of stuff to worry about. And you can only imagine if something goes wrong in a network this size, where do you start? And so problems with topology design, so many switches everywhere, which switch is where, what's handling what. You know, you need to know where your choke points are and how many hops there are. It could, you know, it runs into problems with jitter and latency and things like that, and network load, of course. So lots to worry about in large networks besides the regular stuff. So what to do? We have so many tools, so many varied tools, so many protocols, a lot of complexity, as we just saw in network design, and number of nodes, a lot of pressure on downtime. You know, downtime costs money, and if a network goes down, operations stop, and you're not building things or shipping things or whatever it is your network does. And you know, a lot of networks need 24/7 operation or near 24/7. And so with all of those varied things going on, there are oftentimes just too many network experts needed to figure out a problem. So what to do? Well, you probably guessed, it's Atlas to the rescue. Down here is a picture of the Atlas, and we'll talk about this now for a few minutes. The Atlas is a 24/7 monitoring device. You connect it to your network, permanently installed. It runs Osiris software, and we'll talk more about that in a minute. It is what I call protocol aware for Ethernet IP, PROFINET, Modbus TCP, and EtherCAT. And what I mean by protocol aware is that the Atlas is not just looking at Ethernet packets. It can recognize a PROFINET packet or an Ethernet IP packet or an EtherCAT, et cetera. And it can do special things based on that. It also does things like measure the jitter, which we talked about, the link loads, the network load, cycle time, drop packets, device alarms, all that stuff. It will build you a network topology. We already saw a couple of those examples that I just showed for large networks. The Atlas figures all that out for you. And if you've ever been in the position to troubleshoot an industrial Ethernet network, you know the importance, or any kind of a automation network, you know the importance of having a good drawing or a good network layout so you can figure out quickly where you need to go and what you need to do. So the topology is critical. And then there's also a device list, which is just a list of the devices on the network, and it gives you a bunch of information about each device, the manufacturer, the cycle times, and all that, you know, per device. But it also tells you what firmware and hardware rev the devices are on. So I mentioned earlier, as a common problem, having devices on different firmware revs. This is something that the Atlas can spot for you and flag for you. There's also the concept of a commissioning wizard. Now, some of these features I'm talking about are optional, so you pay a little extra license to get them when you use the Atlas. Commissioning Wizard is one of those. And what the Commissioning Wizard does is when there is either a new installation or an installation that's been around, the Commissioning Wizard will go through a checklist for the particular protocol. So let's say it's PROFINET. It has a commissioning checklist. So if you were building a new PROFINET network, it would check all these items for you to make sure it conforms to the PROFINET spec and recommendations. And it's a really time-saving thing for commissioning, because doing this all manually could take days or hours, depending on the size of the network. Some of those large ones we just saw, I can't imagine trying to commission those without a tool like the Commissioning Wizard. And then over time, as things change in the network, it will also, you can run it to make sure you're still conforming to the spec as things go on, as devices are added or changed or new things happen. So the Commissioning Wizard is a vital tool. The Atlas also has a reporting feature, so you can generate reports and share them with management. And it has the ability to notify you of various conditions, alarms. And you can pick the conditions and alarms you want to alert on, and then you can alert via email, which could be turned into a text message, for example. You could use the onboard relay, which I'll talk about in a second. You could also use the protocol's OPC UA, which is a northbound protocol, as I call it, more like, you know, a DCS kind of protocol. And then there is MQTT, of course, so you can send the alarms to a cloud, your own cloud, for example. All right. So here's the hardware. I mentioned the relay. So there is an onboard relay on here, and that is used for, you know, notifications. So if there is a problem that you want to report in the Atlas, you can turn this relay on, and the output of the relay could go to something like a light tower or an audible alarm or both, or it could go into a remote IO that you're monitoring with an HMI panel, for example, and alert you on an HMI that there's a problem that the Atlas has discovered. And then you can open up the web browser of the Atlas and check it out. Now there is this OLED screen on here. These are little pictures of what you might see on the screen. Like the network name, how long the network's been running, what the IP address is. There's two Ethernet ports. One is labeled factory, one is labeled office. And I'll talk about those in a second. But it tells you the IP addresses of those and so on. So it's just kind of basic information, but it's very helpful if you open it up and you know, okay, what network is this thing connected to? If you open up a cabinet and find an Atlas in there, you can quickly identify what's going on with it. And then there's a couple of USB ports, which we'll talk about in a minute, and of course, a power supply. So just one thing, if you've been around Procentec, HMS Anybus for a while, as I mentioned, they're going through a rebranding. So not everything has got the new white paint. A lot of things still have the old Procentec colors and branding, but things will slowly be changing over to this this white and blue paint from whatever color the Procentec item was. So in this case, the Atlas2 is kind of a black housing there. All right. So measuring and monitoring industrial Ethernet networks. So we talked about permanent monitoring with the Atlas. It can give you that 24/7 watchdog. It gives you an ability to remotely get in there from anywhere. Any experts can get in and look whenever there's a problem. You know, what happens often in factories is the problems always occur when all the experts are gone or all the needed experts are gone. The beautiful thing about remote monitoring is you can have those experts, you know, look in on an Atlas from wherever they are, on the beach, on vacation, or just, you know, home for the evening. So that expert ability doesn't go away when the expert leaves the building. And then usually, you know, Atlases are installed one per network, and we'll get into that, but sometimes per subnet, but there are also places where you might have multiple Atlases on the same network. And then, you know, it's an expense to install an Atlas. So typically people make sure they put them on their most important networks. And if you have, you know, a lot of industrial Ethernet networks and maybe downtime on some isn't as critical as it is on others, you could go for something like this Mercury tool. It's a portable tool, and it has the same software that runs on Atlas, so that's Osiris. And you can move this from your non-critical networks, just to check out what's happening in each of those. And so there you go. I'll talk about some of that other stuff in a minute. So the Osiris software, that's what I just mentioned, runs on the Atlas. I keep calling it Atlas, but technically it's the Atlas2 now. The Mercury tablet, and you can also get it as a service, basically a license on a Windows laptop. You can also run the Osiris software there. So some factories, each person has their own laptop. Each maintenance personnel has their own laptop, but if you wanted a shared tool, you could go for a Mercury. If you want everyone to have their own tool, you could, of course, put it on laptops as a license. And the Osiris software provides a lot of things, including a simple traffic light and quality score, that's the Q factor, but also some really critical things that help you figure out what's going on, the device list, the topology, a link list, etc. And as I also mentioned just a little bit ago, there are extra licenses for the EtherCAT part of this and the commissioning wizard. And the Osiris software also offers that OPC UA and MQTT connectivity, which I mentioned for alarming. So this is a look at what the Osiris dashboard looks like. My apologies, this is the Procentec branded one. There is now, there's now a HMS branded dashboard. And the dashboard has a variety of things which we'll get into later, but I just wanted you to kind of see what that looks like here. And so we'll go through some of that in the demo in the following slides, but I just wanted you to get an idea of what the apps are that are available, the topology and all that I mentioned previously. All right, so I want to talk a little bit about active and passive monitoring. So active monitoring is when you plug an Atlas into your network and it gathers information by sending out messages with using specific protocols to gather information about the network. So the network is adding traffic to your network, but it does so at a very measured and low level so that it does not really impact your network load at all. It's less than 1%, typically even much less than that. And some of the protocols used, well, one of the big important ones is SNMP and LLDP, but all of these are used for various things to help the Atlas figure out what's happening. And as I said, it uses these messages and protocols to kind of determine what is on your network, where it is, how it's connected, and what's happening. You can also have, so the Atlas can scan any range of IP addresses you want it to. And that's called a scan list. You can define up to 10 separate scan lists within a single Atlas. And it will go and do that. So if you want it to scan the world, it will take a very long time because if you give it the full range of IP addresses, it would take a very long time for it to do its stuff because it's going at such a low level. And it would check a bunch of IP addresses that aren't on your network. So, but it would still do it because that's the range you gave it to scan. So I recommend when you get an Atlas that you think about what scan range you want it to work with for active monitoring. Now, passive monitoring requires something called the network tap, an EtherTAP we talked about earlier. And the EtherTAP feeds the captured or sniffed packets from the network. There's no messaging going on from the Atlas over the tap. It's just listening to the network. And then based on what it's listening to, it can do a message capture if there's a problem, and then you can download that and use it with Wireshark. Now, I'm going to talk about that in detail in a few minutes, but that's the passive monitoring side. Okay. So I mentioned you need an EtherTAP in order to do the passive monitoring. And there's two flavors. There's this portable EtherTAP that you can use with the Mercury tablet or your laptop. And then there's a permanently installed version, which looks very similar to the Atlas itself. Same paint job, same form factor, just different connectors. But this is where you would basically tap into your network. And the way you do it is, if you had, for example, a controller or switch, and you wanted to do passive monitoring with your laptop, well, the traditional way is you have to set up a monitor port, you have to get an IP address on your laptop and connect it to the switch, and then you would see the traffic going to and from this controller. With the tap, what you're doing is interrupting this flow here by sticking a little tap in the middle, and then it sends the data over a USB cable. The device is actually powered through the USB cable, but it does not. If this were to lose power, this traffic would continue to flow. So you can permanently install an EtherTap on your network, and even if it lost power or lost its mind, the traffic continues to flow through the tap. And like I mentioned, you can plug an Atlas in. Now, this is the original Atlas, so I still have some old slides in this presentation. This is the Atlas1, if you will. They just beefed it up with the Atlas2. It's got more horsepower, and it's got the OLED screen. And so, as the applications continue to evolve for Atlas, they needed an upgrade in processing power and so on. So that's the Atlas2 Plus. But they all function the same way. If you have an old Atlas, it's still good. But if you want to upgrade to an Atlas2, let us know. Okay, there's still another way, because when you do passive monitoring, like I mentioned, if you had this setup, you have to disrupt the connection from the controller to the switch to insert the tap. So if you had multiple networks in your facility that you just wanted to use a Mercury tablet to monitor, you could install something called an Ether mirror, which is permanently installed on the network. It's a relatively inexpensive little box. And then you can come in with your EtherTap and connect it to, you can connect it right to the EtherTap, and you get bi-directional traffic. So two of these go from the switch there, and then the mirrored ones go into the EtherTap that the Mercury can gather the information. So you just install this permanently, and again, it doesn't disrupt the traffic if it were to lose power, and the Mercury taps in this way. Okay. So where do you position Atlas on your network? Well, for active monitoring, that is when you plug in an Atlas and it sends out messages to gather information. The answer is it doesn't matter where you connect it. You can connect the Atlas to any open switch port in your network. So here we just connected it to this OT switch. And by OT, I mean operations technology. And that's connected to the factory port of our Atlas. And the factory port might have an IP address range, something like this, 10.0.16.254. Here we see an engineering workstation on the factory network, 10.0.16.154. And the idea with Atlas is like you can get to it from anywhere. So from the office port, you can put in whatever IP address you assign to the office port, in this case, 192.168.810. So on my laptop, which has the .20, I can put this IP address in a browser and then see what the Atlas is presenting to me. So that can go into your IT switch, but it can also be a separate OT network or what have you. You can also, like for example, from this engineering workstation, put in the IP address of the factory port and see the same web browser information from here on the factory network itself as well. Okay, so that's active monitoring, connected anywhere. Oh, real quick, if you want to do a direct connection without a switch, you can do that. So if you just had an open office port and it wasn't connected to anything and you walked into that cabinet, you could still connect your laptop and see what's going on with your Atlas that way. Okay, now for active monitoring, it's a little different story. You want to be where the controller is, because you want to be able to tap into that traffic that goes between the switch and the controller. So here we put I showed the portable tap, but you could use the new EtherTap 2 permanently installed one. and connect it to the Atlas2 here. So it's basically the same idea, but you have to put the passive monitoring point on here. It sends the data in here. And the active monitoring still comes in through an Ethernet connection to the factory port. All right, so let's say we have a complex network with 3 controllers and an HMI and a bunch of devices. We have different architectures, line architectures, 3. So this is like a mini complex network, if you will. We have a bunch of switches, 1, 2, 3, 4. And once again, for active monitoring, as I mentioned, you can plug in anywhere. Doesn't matter. I'll plug in here and I'll get the same information if I had plugged in here, because it's going to send out this discovery messages using the IP scan range that you gave it. And then if I want to do passive monitoring, well, like I said, I have 3 controllers. Now that's a pretty unusual situation where you'd have 3 controllers, but just for illustrative purposes here. Now I'm tapping the traffic between each controller and its switch with EtherCAT, and then I can connect my active monitoring to all these switches. So, and HMIs, for those of you who don't know, typically can use the same protocol as the control network. So it would use like PROFINET to gather information from the PLCs and devices to display on the HMI, for those that are running the process there. All right, so now we already have one Atlas that is doing the active monitoring. So this Atlas, if it's doing active monitoring and this one, it's going to get the same information. So you don't really necessarily need to connect these other 3 to an open port, because they're going to gather the same information, and you'll be putting 4 times the traffic, the monitoring traffic on there. Now you could use different scan ranges. So for example, this, if you wanted to leave them all on active monitoring, this one could just scan, let's say these were the devices used by this PLC, which I would guess is probably the case in this drawing. So you could use IP scan ranges in each Atlas to kind of segment who does what. But you can also just leave them off. And then you can, connect other traffic, unknown traffic, and I'm going to go into this a little bit more in a second, but if devices get connected to your network and people start adding devices to your network, that can cause, if the number of hops changes, you go through 7 switches, for example, that can cause problems, or your update times get out of whack on your process, and then things stop working. So we'll talk about that in a minute. All right, so we'll talk about here is what to do when someone comes in with a laptop and maybe causes a problem for you. So, so in this case, this is the device list, and we have our, these are the device names for PROFINET. So these are settable by the PLC programmer and the commissioning staff. Here's their IP addresses. This is their status. They're online, how long they've been connected, so on, what the model is, who the manufacturer is. And then this would be what an example of the topology looks like. So here we have the Atlas up here connected to our network, and then these other devices. Now, if I come in with my laptop, the device list shows a new device, online, unknown. And when I look at my topology with my laptop connected, all of a sudden I show this like Ethernet port. Well, it's it's my Apple PC that I connected, and this was the IP address I used, and that's how long I've been online and so on. So you can get all that from the topology view. Now, when I disconnect my Atlas, it will show it as lost. So it'll flag it as a problem. And sorry, I clicked off my screen there. So now it will show it as lost. It'll give me the time that it went lost. So 5:20, 5 p.m. here or whatever. I can also click on this little red alarm bell, and that logs all of them. This also gives me a timestamp up here and the date that it happened. All right, network load. I talked about network load. So some of you might be saying, well, Ethernet switches do have we do get the port load. So why do we need the network load? All I have to do is get the port load on the switch that's connected to the controller, and that's the load I care about. But the network load is one thing that the EtherTAP also provides over the USB. It's the load of that link. And it does a much better job of calculating the load because that's all it has to do. Whereas switches and overload may not provide accurate calculations on the link load. It's a secondary calculation. You know, we talked about it dropping packets. Well, it's also not going to accurately calculate things when it's dropping packets or discarding packets and so on. So this is an example of the screen on the EtherTAP. As I mentioned, the EtherTAP measures the actual load, and you can see the network load is calculated here and shown. So we'll show that in the live demo when we get a chance here in a minute. All right, so I want to talk about Wireshark captures. And the reason that this is sort of a critical thing is to do it the traditional way, like I talked about before, it really is not a trivial thing. First of all, there are typically multiple people involved. You need maintenance engineers and maybe you know, some higher level engineer that might want to do a Wireshark analysis. And so you got multiple people involved, and it might seem simple, but you have to find which cabinet in your facility has, has the controller connected to it that you are interested in getting a Wireshark capture on. Because as I mentioned, you want to capture the traffic from the controller to the network, to and from. So you have to find that switch. What cabinet is it in? Where is it located, etc. Then when you find the switch, you have to hope there's an open port on that switch so you can create a mirror port. Ideally, you might need two ports, one for you to connect your laptop to set up the mirror port. Some people call it a monitor port also. So you might even need two open ports. Now, okay, so now you figured out which cabinet has it and it has available ports. Now you have to find out what IP address can I assign to my laptop so I can enter the web server console of the managed switch. And I'm talking about managed switches in this case, and you should always use managed switches in industrial networks. And so anyway, so you need to figure out which IP address you need, and then you have to set it up on your laptop. Now we can go open the cabinet, and hopefully it matches the drawing or whatever it was we used to figure out there's an open port and what IP address we can use, and no one else has added anything to the network with an IP address we don't know about. And so you go in there and you have to open a cabinet. Well, some places require a lot of safety gear depending on the voltages present within a cabinet, and even permits from safety organizations, and you have to within the facility, and then you have to, you know, put up some safety tape to keep people away while you have the cabinet open. And so, you know, it's an effort just to open a cabinet in some cases. And then now you're in the cabinet, now you can use your laptop. Hopefully you don't have a lot of safety gear on. And then you can get into the web server. Now each switch manufacturer has their own web server and their own way of, you know, how you set up a monitor or mirror port. And so once you're in there and you figure out how to use their web server, then you can initiate the port mirroring. And then you can set your laptop to accept it for they call those PCAP files that Wireshark uses. And then you can finally capture that data for Wireshark. And then when you're done, you have to undo all that stuff. You know, you don't want to leave that mirror port there. If someone were to try expecting it to be a regular port and plug into it, that could cause problems. So you either have to update your drawings and mark it as a mirror port, or you have to undo everything that you did. And so the long and short of this whole story is that it can take anywhere from, you know, a half hour to several hours of effort, depending on what's going on, just to get a Wireshark capture. And by the time you go through all that, the problem that caused you to want to get the capture is probably either over or, you know, not occurring at the way it was already because people have been trying to figure it out. So Wireshark captures are sort of the last resort when you just can't figure out what's going on. But the beauty the beautiful thing is with an Atlas, you can get it instantly. If you have that EtherCAT connected, you can just request it at any time. I could go in right now to an Atlas and request a Wireshark capture. You don't have to go out on the factory floor. You can do it, as I said, on demand right now, or you can set up events and alarms where it will do a message capture for you when something occurs in the network. And the nice thing about this is you're getting that data at the time the problem happens. And that's the most critical time to get it. And then the other thing about using an Atlas is, mirror ports, if the switch is an overload, could drop packets, could drop messages, discard them, and also put them in the mirror port out of order, because it's buffering and trying to do its first job of switching first. The switches could get the messages could get copied to the mirror port out of order in which they actually occurred. So then you end up with, out of order messages and all that. This is just an example of what Wireshark looks like. And you can do color coding. In this case, we've color coded, the normal PROFINET IO traffic in green, and we have DCP messages up here in yellow. We have ARP messages here in light purple. And so you can use these color coding schemes to help you figure out what's going on with Wireshark. Okay, that's enough about that. All right, we're into the demo. So let's see, how much time do we have? It's running a little late. Apologize for being long-winded here. I'll get a demo open here for us, and we'll take a quick look. So here we go. This is a live running demo, and it is in the Netherlands, in Rotterdam, I believe, or maybe it's Delft now. Anyway, they have some test networks that they use for R&D, and you can actually log into this at atlas.prosentech.com. Don't everybody go do this all at once, because sometimes it can cause overload in the Atlas. It's not really designed to have a bunch of people connected at once, but it can certainly support multiple people, but maybe not 50. All right, so this is the new Anybus branded homepage, the dashboard, if you will. And here's all the different things we can see. We have our topology, our queue factor, traffic light, link list, settings, etc., EtherTAP messages down here. So let's take a quick look at some of this stuff. So here is the topology. And this is what's known as the galaxy view. So it's sort of, there are devices here in a galaxy, and I can arrange them however I like. And once I get the arrangement I like, I can save it as a view that I like. So I can come up here and create a new view and then save it. And then it will arrange the devices however I've arranged them in my Atlas. So anytime I come back, if I have a view that's called Rick, I can come in here and pick my favorite view. You can also use what's called the tree topology, and it creates this tree for you. Here we show on this tree, it puts Atlas at the top because, well, that's what it does. But if let's say I wanted to put my PLC at the top, which kind of makes more sense. So I think this is the PLC. And I could assign this as the top node. So now in my tree, I have my controller or PLC at the top. And then this is the switch that goes to the PLC. I know it's connected port 8 of this switch to port 1 of the PLC. So if I wanted to do a tap, I'd put it right here. And then it arranges it in a little bit more structured way for you. And we see the port information, port 2 of the switch connected to port 1 of this switch, and port 2 of this switch connected to port 1 of that switch, and so on. We see a lost device over here that connected, and a question mark means that there is a device, or there's an unmanaged switch or switches in the network that don't provide the necessary information to the Atlas to determine what is happening here. So it knows something is out here, or some things, but they're not responding to SNMP and LLDP for Atlas to be able to figure out the port numbering. So that would also be an indication that you need to go turn something on and get it configured so that you get a nice full network view, or get these unmanaged switches out of your network. As I mentioned, you want managed switches. Okay, so that's the topology. Now I can click on a device. Let's just go back to our PLC, for example. And it gives you all the details you need to know about it, the IP address, the status. It's been online. It's been up for, I think that's 275 days, 9 hours, 13 minutes, and 56 seconds. You can assign devices to groups. So if you just want to look at certain groups up here, I can do that. So if I just want to see PROFINET devices, if I had assigned this to that device, to the PROFINET group, then they would highlight the PROFINET devices for me. So there they all are. Our switches are PROFINET devices. You can also belong to more than one group. Like this one belongs to the Atlas2 Plus group and PROFINET. So it belongs to 2 groups. So that's why it's half green and half red. All right. So that's topology. I wanted to show you quickly the network load, as I showed you earlier. So if you have an EtherTAP, which I hope you do if you get an Atlas, you can see stuff specific to PROFINET. So here we have a warning for PROFINET status that we've had some drop packets on this node, and we can troubleshoot the reasons for that. If there have been any alarms with the devices, they would show up here. And then this telling you why, just because of drop packets. But this also gives me my min-max cycle times. And so that's pretty interesting if you're a network engineer trying to figure out issues. And then, oh, sorry. So if you go to just the plain Ethernet view, that's where your network load pops up. Of course, it's showing that I had 50 CRC errors in Ethernet. That's like a data integrity check, cyclic redundancy check, they call it. So it makes sure that all the bits in the packet are as they're supposed to be. It's a calculation that's done, and so it's found 50 errors. So we're having some issues with interference. Maybe it's EMC or something that's causing some of the bits to get messed up within certain packets, and we've had 50 discards. This would be something to investigate probably on your physical layer, as why are we getting errors in certain packets. So there's the network load. If you wanted to do alarming, we come to the settings here, and if you go to the alarm configuration, you can see these are the things that we can alarm on. So they're down the left side here: lost device, in errors, in discards, out discards, ping packet loss, ping packet response, how long does it take for a ping to come back, and then max link load. Like if you wanted a link load nothing higher than 20 is a warning, and anything greater than 50 is an error. We're going to do a notification, and we'll display it in the traffic light on the Atlas. We'll send an email out. We'll send it MQTT to our cloud. We're going to send it OPC UA also. We're going to turn the relay on. So these are all the actions that you can take, and I can edit these actions by just clicking this. And then other errors, we can have DCP errors. That's basically when a device goes lost or it's in a configuration of a controller or PLC, and the device isn't responding. It's basically a DCP message trying to locate the device. So we don't want to be seeing a lot of those DCP messages. And then if you have EtherTAP, which, like I said, we hope you do, you can alarm on PROFINET alarms, and then jitter, drop packets. Sorry, I'm having a hard time scrolling down. Okay. And then for Ethernet IP, similar kinds of things you can, and then on the network compare, that's the thing where I connected a laptop and disconnected a laptop. So if there's devices with different firmware, we can alarm on that. If there's missing devices, if there's new devices. And then we also have Combrix alarms. Now, what's Combrix? Well, Combrix is another product from HMS Anybus Diagnostics that monitors Profibus networks. But because a lot of people had Profibus and PROFINET at the same time and wanted to use Atlas, they decided to add in a reporting feature where the Combrix could report its information in through an Atlas. So you have one interface to be able to view that information and also alarm for it. So everything through, through the Atlas if you have Profibus. All right. Something in the chat. With the mirror product, do we still need an EtherTap? Okay. So for the EtherTap, let's see if I can move this out of the way here for a second. Back here. Okay. Yeah, so the mirror, in order to concentrate the traffic, because it has a in and out, you need the in and out for the tap, and it concentrates it on into one data stream on the USB. So yes, you do need an EtherTap and an Ether mirror. The Ether mirror is your connection point for the EtherTap, but it's still bridging both sides, the in and the out of this this link. Okay. And there are a lot of problems with switches, but we have a lot of great PROFINET managed switches. And a PROFINET switch, which I didn't talk about, is a switch that also is a PROFINET device on the network. So it can report information about its status to the PLC, as well as, reporting it to Atlas over SNMP. So you got kind of two ways for these switches to be on your network as a PLC, as a PROFINET node, for example, and also as doing its job as a switch. And some really great prices on some of these switches. You'd be surprised at how the prices have come down on some of these managed switches. So reach out to us if you have a need. We use ATOP and Teltonica switches. All right, well, if you have questions, feel free to reach out to the sales team. Excuse me. This is our main line number. You can reach any of our sales team by calling that number and just asking for us. Our email addresses are also there for you. And I think with that, we have reached the end of our webinar. So thank you, everyone, for your attendance.